Hey, welcome back to geometry. We are now at the last two sections of chapter 5, and this is relationships within triangles. These last two sections are about inequalities in triangles. Section 5.6 is inequalities in one triangle, and section 5.7 is inequalities in two triangles. We're going to explore them both in this lesson. So our objectives are this: to use inequalities involving angles and sides of triangles, to apply inequalities in two triangles. It's essential that you understand the angles and sides of a triangle have special relationships that involve inequalities. Remember, inequalities: greater than, less than, greater than or equal to, less than or equal to. In triangles that have two pairs of congruent sides, there is a relationship between the included angles and the third pair of sides. So we're going to explore these concepts in these two sections. Theorem 5.10. If two sides of a triangle are not congruent, then the angle lies opposite the longer side. So if this side, xz, is greater than this side, xy, then that means that the angle that's across from xz, angle y, is greater than this angle, angle z. So the bigger angle is across from the bigger side, the smaller angle is across from the smaller side. That's the gist of this. The medium angle is across from the medium side. Take a minute, pause, so you can write this down. Theorem 5.11. Same idea. If two angles of a triangle are not congruent, then the longer side lies opposite the larger angle. So if the measure of angle A is larger than the measure of angle B, then the side that's across from angle A, CB, is greater than the side that's across from angle B, CA or AC. Larger angle is across from the larger side. The smaller angle is across from the smaller side. Therefore, this would mean that this third side here, AB, is across from angle C, and therefore angle C is the medium angle. So if we were going to list them in order from largest to smallest, you would say the measure of angle A is greater than the measure of angle C, which is greater than the measure of angle B, if you were going to list them in order, which is exactly what we're going to do right now. We're going to write the measurements in order from least to greatest. So write the measures of the triangle in order from least to greatest. So in example A, we're given the angles, so we don't want to list the angles in order, we want to list the sides. Remember, the smallest angle is across from the smallest side. So angle C is the smallest angle of these three angles, which is 37 degrees. Therefore, the side across from angle C is the smallest side. So segment AB is the smallest. It is less than the medium side. Well, the medium would be across from the middle angle, right? 55 is across from this side, CA. So segment AC or CA is the medium one, the middle. And then the largest angle would be the angle that is across, is 88, and therefore the largest side is the side that's across from the largest angle, which would be CB or CA. So segment AB is the smallest because it's it's across from the smallest angle. So AB is the smallest. Then AC, because it's across from the next angle. And then CB or BC. So now let's look at example B. Let's name the angles from least to greatest. Well, we're given the sides. What's the smallest side here? Yeah, DF. DF is the smallest side, therefore it's across from the smallest angle. So angle E is the smallest angle. Then the next in size would be 12, which is EF. It's across from the next angle, which is angle D. So angle E is the least. Then we have angle D. And then the greatest angle would be the one that's across from the greatest side, the largest side. So it would be angle F. So from least to greatest would be angle E, then angle D, then angle F. So the smallest side is across from the smallest angle. The medium side is across, or the middle is across from the middle sized angle. And the largest side is across from the largest angle. And conversely, the smallest angle is across from the smallest side. It's the opening that they make is what the angles are. They make that opening, like a hinge, like a door. So when these two sides open up, they make the smallest side. They need the smallest opening, therefore that's the smallest angle. We had the triangle exterior angle theorem. We said that the exterior angle, this one here, is equal to these two added together. So therefore the corollary, the thing that's easy to prove here, is that the measure of the exterior angle of triangle is greater than the measure of each of the remote interior angles, so the ones that don't touch it. So angle 1 is greater than both angle 3 and angle 2, because we already knew that the measure of angle 1 was equal to the measure of angle 2 plus the measure of angle 3. That was the exterior angle theorem, and therefore angle 1 is greater than each one of those individually. Write an equation about the angle measures labeled in this diagram. Well, the exterior angle, angle 1, the measure of angle 1 is equal to, equation means you're going to have an equal sign, the sum of the measure of these two angles, the measure of angle 2 plus the measure of angle 3. If you look back in your notes, you'll remember that we proved the exterior angle theorem back in chapter 4. We said that angle 1 was adjacent to this angle, and they are a linear pair. They formed 180 degrees. And also this angle plus 2 and 3 equals 180. So we proved that 1 is equal to the sum of 2 and 3. So then write two inequalities about the angle measures labeled in the diagram. Well, these two inequalities would be this, that the measure of angle 1 is greater than the measure of angle 2, and also that the measure of angle 1 is greater than the measure of angle 3. Triangle inequality theorem. The sum of the lengths of any two sides of a triangle is greater than the length of the third side. So in order for three sides to make a triangle, two of them always have to be larger than the third. So really the rule here is if the two smallest sides add together to be greater than the third side, then it can make a triangle. If it's equal, it would just lie straight flat on it. We'll explore that in class. But the two smaller sides of a triangle always have to add together to be greater than the largest side. That's really the rule here. So let's use this triangle inequality theorem to see if these three sides can make a triangle. So really I want to focus on the two smaller sides. 3, 3, and then the third side is 8. That's the largest side. If I say 3 plus 8, it's greater than 3 every day. But how about this? Is 3 plus 3 greater than 8? Because the two smaller sides, when I add them together, are not greater than the third, then this is not a triangle. That will not form a triangle. The two smaller sides always have to be greater than the largest. So let's look at B. What are the two smaller sides here? 6 and 4 are the two smaller sides. The largest side is 12. When I add 6 plus 4, is it greater than 12? 6 and 4 is 10. 10 is not greater than 12. So these three segments cannot form a triangle. Not a triangle. Let's take a look at this last example. What are our two smaller sides? Our two smaller sides here are 9 and 5. The largest is 11. If I say 5 plus 11, it's greater than 9. If I say 9 plus 11, it's greater than 5. So really, we have to just look at the two smaller sides here. Is 5 plus 9 greater than 11? Well, 5 and 9 is 14, and 14 is greater than 11, so yes. These three sides can form a triangle. This makes a triangle. So A didn't work because 6 is not greater than 8. B didn't work because 10 is not greater than 12. C worked because the two smaller sides of this triangle were greater than the third side. Let's find some possible side lengths using this theorem. So if a triangle has one side of 12 inches and another side of 16, describe the possible lengths of the third side. Well, draw a hypothetical triangle so that you can envision it perhaps. So I have 12 and I have 16. This one, this third side, could either be the smallest side or it could be the largest side. But I don't know which. I do know this, that side, which I don't know, plus the next smallest side, 12, has to be greater than the third side, 16. Because if that's the smallest side or even the medium side, it has to add together to be greater than 16. So x has to be greater than 16 minus 12 is 4. X has to be greater than 4. It can't equal 4. It has to be greater than 4. Additionally, what if this was the largest side? That means that 12 and 16 have to be greater than that side. 12 and 16 is 28. 28 has to be greater than x. So x has to be less than 28. So x can be in this range between 4 and 28. So x has to be greater than 4 and less than 28. So I could express that in this inequality. X can be between these numbers, 4 and 28. It can't be equal to them, so x has to be greater than 4 or less than 28. That would be the solution. Let's try another one. So we have a triangle that has one side of 2 centimeters and another side of 5 centimeters. So we have this triangle. It's got a side of 2 and a side of 5, and we don't know the third. Or you could depict it differently and say that it has a side of 2, a side of 5, and we don't know what this third could be. It could be the smallest side. So we could have 2 and 5 and have this one be the x. We don't know. So all three sides, when you add any two together, they have to be greater than the third. That's the rule. So we know that when we add x plus 2, they have to be greater than 5. We also know that when we add 2 plus 5, it has to be greater than x. And then finally, we also know that x plus 5 has to be greater than 2. So these are the 3 different combinations. Every 2 sides has to be greater than the third side. So for this first one, x plus 2 is greater than 5. When you solve it, you would subtract 2. So x has to be greater than 3. It can't equal 3. It has to be greater than 3. For the second one, 2 plus 5, which is 7, has to be greater than x. So x has to be less than 7. And then this final one, x has to be greater than negative 3. Is that a valid one? If x is greater than 3, isn't it greater than negative 3? And can you really have a negative triangle? So really, the 2 important ones are here. This one and this one. We didn't really need this third one. So x is between these 2 numbers. X can be between 3 and 7. X has to be greater than 3, and x has to be less than 7. It can't equal them. So x can be 4, x can be 5, x can be 6, x can be 4.7, 5.3. Has to be some number that comes in between 3 and 7. Even 3.2 will work, or 6.8. Moving on to 2 triangles, the hinge theorem. If you would think of this as anything you could think of with hinges, a cabinet or a door, if you open the door a little bit, then you have a little opening. If you open the door wide, the hinge is wide, then you have a wide opening. And that's what this is like. So pause the video if you need to write down this theorem. If 2 sides of one triangle are congruent to 2 sides of another triangle, and the included angles are not congruent, so kind of like side angle side is what this is like, then that means the larger angle is across from the larger side. So even though in this triangle these sides are congruent, the angle in between, the included angle, is not. So it means these 2 triangles are not congruent. Because angle A is greater than angle X, that means this third side, BC, is greater than this third side, YZ. The converse of that, the backwards, is this. It's kind of like side, side, side. If 2 sides are congruent, so again, you have side and side, but the third side is not. This third side, BC, is larger than this third side, YZ. That means these triangles are not congruent. That means that the angle inside there is larger than the angle in there. Let's use the hinge theorem. It's easier than it sounds when you're writing down the theorems. Complete with greater than, less than, or equal to. The measure of angle 1 to the measure of angle 2. Well, if angle 1 is across from a side that's 20 and angle 2 is across from the side that's 21, then which angle would be the larger angle? Angle 2 would be larger than angle 1. So angle 1 is less than angle 2 because it's across from the smaller side. BC and EF. BC is across from an angle that's 50. EF is across from an angle that's 60. 50 is smaller than 60, therefore BC is less than EF. GI is across from a 90-degree angle. JL is across from a 90-degree angle. If these sides were congruent, and the third side is both across from a 90-degree angle, then these triangles are congruent. Those sides are equal. You could use side angle side to prove it. Take a look at these. MN and QP. If this side is congruent to this side and this side to this side, what do you know about MN and QP? Well, you might remember from chapter 4, these are vertical, well, it started in chapter 1. Those are vertical angles, but we can prove these two triangles are congruent using side angle side. Because these angles are congruent, all of the corresponding parts of these triangles are congruent. So these, again, are equal. Number 5, the measure of angle 1 to the measure of angle 2. Well, these sides are congruent. Angle 1 is across from a side that's 16. Angle 2 is across from a side that's 12. 16 is what to 12? Therefore, angle 1 is greater than angle 2 because 16 is greater than 12. If this side is congruent to this side and then they share this side, so it is also congruent, let's look at AD and BC. Well, AD is this side. It's across from that angle. BC is this side. It's across from that angle. That angle's 40. What is this angle? That's a right triangle. It's got a 90 and a 45. So that means that this angle over here would also be 45. And if this is 45 and AD is across from it, and this angle is 40 and BC is across from it, what is AD to BC? 45 is greater than 40, so AD is greater than BC. Finally, our last example, finding possible side lengths and angle measures. You can use the Hinge theorem and its converse to choose possible side lengths or angle measures from a given list. At the right, segment AB is congruent to DE, and segment BC is congruent to EF. AC is 10 centimeters, and the measure of angle B is 60. Measure of angle E is 130. 130 is what to 60? It's greater than. What are some possible measures for DF? Could DF be 5? 130 is greater than 60. Therefore, DF has to be greater than AC. So 5 would not work. Could it be 10? 130 is greater than 60. Is 10 greater than 10? It would not work. So 15 would be the only possible one here that could work. 15 centimeters could work because it's greater than 10. So it could work. What is the range of possible values for x in the figure at the right? Well, if this side is 9 and it's across from a 90-degree angle, and this side is 7, what do you know about this angle? 7 is what to 9? 7 is less than, 7 is less than 9. Therefore, the angle across from 7, 3x plus 18, has to be less than this angle, which is 90. So solve this inequality. So when you solve this inequality, you would subtract 18 and then divide by 3. So x is less than 24. So x would have to be any number between 0 and 24. That would be our possible range of x values for this figure at the right. That's the end of this lesson. Please make sure you bring your notes with you to class tomorrow. We will practice these concepts before we review the chapter and have the chapter 5 test.